Postman is an excellent tool. It is visual, approachable, and fast for exploration and ad hoc testing. But it has a ceiling, and that ceiling matters for teams that take quality seriously. You cannot easily version control a Postman collection, not in a way that integrates naturally with GET and pull request workflows. You cannot parametrize a test across hundreds of data rows without building workarounds. You cannot run a Postman collection in a GitHub Actions pipeline with a simple command and get CI native test output. For all of that, you need code. And in the Python world, two tools handle this better than anything else: the requests library for making HTTP calls, and pytest for structuring and running tests. Together, they give you everything Postman gives you plus the full expressiveness of a programming language, a mature test framework, structured fixtures, parametrization, CI-compatible output formats, and a codebase you can review, refactor, and maintain like any other production code. This video is about building real, production-grade API tests in Python. We are going to set up a project from scratch, write test functions, use fixtures to share setup code, handle authentication properly, test error cases deliberately, and structure everything so a team can actually maintain it long term. If you know basic Python, you are ready right now. Start by creating a new directory for your API test project and navigating into it. Create a Python virtual environment with Python env, then activate it. On Windows, that is venv/scripts/activate. Install your two core dependencies, pip install requests pytest. If you want HTML reports for CI, also install pytest HTML. Create 3 files at the root level. First, conftest.py. This is the special file pytest looks for automatically when it starts up. Fixtures defined here are available to every test file in the project without any import. Second, pytest.ini, the configuration file for pytest. Set test paths to point at your tests directory, and define custom markers like smoke, regression, and security so you can run subsets of your suite independently. Third, config.py, a dedicated place for environment configuration. Use os.environ.get to read the base URL from an environment variable, with a default value for local development. Hardcoding URLs into test files is a maintenance problem that compounds as the suite grows. One config file, one change, and every test in the suite points at a new environment. Create a tests directory and inside it, create your first test file, test_posts.py. Your project skeleton is ready. Open test_posts.py and write your first 3 tests. Import requests at the top. Import base_URL from config. Your first function, def_test_get_post_returns_200. One line inside, call requests.get with the posts endpoint base_URL plus /posts/1 and assert the response status code equals 200. Run pytest from your terminal. 1 test collected, 1 passed. Write a second function, def_test_get_post_has_required_fields. Same request. Call response.json to parse the body. Assert that each of the expected keys ID, user ID, title, body is present in the returned dictionary. Using the in operator against a dictionary checks keys, which is exactly what you want for field presence validation. Run pytest. 2 tests, 2 pass. Write a third, def_test_create_post_returns_201. Use requests.post this time, passing a dictionary as the JSON keyword argument title, body, and user ID. Assert the status code is 201. Assert the return JSON contains a title key matching what you sent. 3 tests. 3 passes. You have covered the 3 most common patterns: a read, a field validation, and a create in about 15 lines of code. That is the foundation every API test suite is built on. Fixtures are the feature that makes pytest genuinely powerful for API testing. A fixture is a function decorated with pytest.fixture that provides reusable setup to any test that requests it. Open conftest.py. Write a fixture called API_session. Inside, create a requests session object. Set the session's base header's content type application/JSON, accept application/JSON, and your authorization header if the API requires one. Yield the session at the end rather than returning it, which allows cleanup code after the yield to run when the test finishes. Any test function that lists API_session as a parameter automatically receives a preconfigured session. No repeated setup code in individual tests. Auth tokens configured once, inherited everywhere. Parametrize is equally powerful. Decorate a test function with pytest.mark.parametrize, passing a list of argument tuples. Write one function that tests a post's endpoint with IDs 1, 5, and 10. Pytest runs it 3 times automatically, once per input set, and reports each as a separate test result. The pattern scales to any number of inputs test data loaded from a CSV, generated from a range, or defined inline. Instead of 20 nearly identical test functions, you write one and let Pytest multiply it. This is how coverage grows without code rot. Real APIs require authentication, and handling it correctly in a test suite is the difference between a suite that works and one that breaks the first time a token expires. The 2 patterns you will encounter most often are API key authentication and bearer token authentication. For API keys, configure them in your session fixture as a header, typically authorization with the key value, or a custom header like XAPI key that the API documents. For bearer tokens, the header value is the word bearer followed by a space followed by the token string. Set both at the session level in your fixture so every request inherits them without any per-test configuration. Store the actual token value in an environment variable never in code and read it in the fixture using os.environ. Now test the authentication itself. Write a test that sends a request without the authorization header and asserts the response as 401. Write another that sends an expired or invalid token and asserts 401. Write a third that sends valid credentials for an account with limited permissions and tries to access a resource that account should not have, assert 403. Error case testing is the most neglected part of API test suites and the part most likely to catch real bugs in production. The happy path works most of the time. The failure paths are where software breaks in ways that hurt users. You now have a complete foundation for Python API testing. You can set up a project with proper structure and configuration. You can write clean test functions that are specific and readable. You can use fixtures to share session setup and authentication across your entire suite without repetition. You can parametrize across datasets to get broad coverage from a small amount of code. You can test error cases deliberately, the wrong credentials, the missing fields, the unauthorized access, not just the happy path. This is the skill set that makes a QA engineer genuinely effective at API testing, not just capable of sending requests. In the next video we move to GraphQL. If you have only ever worked with REST APIs, GraphQL will look different at first. One endpoint, a query language instead of discrete routes, a type system you can introspect. But it is increasingly common in production applications at companies like GitHub, Shopify, and many others, and knowing how to test it is a real competitive advantage. Subscribe and we will cover it thoroughly tomorrow. QA Career Lab Python API Testing, complete.